Hello guys, welcome to the class. This is yours JK. Today we are going to discuss about what is the design process of ball or roller bearing, and after that what are the formulas will be helpful to design a suitable and as well as the efficient ball or roller bearings. So let's see what are the design steps involved here. It is the first step. Here we are going to find out what is the equivalent load acting on the bearing. So it is denoted by capital P. So that is equal to V into X into FR plus Y into F suffix A into S. So this is the form to find out the equivalent load acting on the bearing. So here let's see what are the terms will be involved here and how we are consider their values. The first one is here V is the race rotation factor, and X and Y are the axial and as well as the radial load factors. X and Y are the radial and axial load factors, and FR and FA are the which type of loads are acting on bearing. That means it is the axial load and it is the radial loads. And one more thing is there, that is the S. That S is the service factor here. Okay, so these are the terms involved in the equivalent load condition. Let's see how we are consider these values at the time of design point of view. For that purpose, I prefer the design data book. Why? Because in some problems we doesn't know these values. That means in case service factor or maybe radial and axial load factors. So that's why we are using the design data book to consider the proper values. Okay, first of all, here I am introducing the chapter number 20 in the old edition of MD Jalaluddin Design Data Handbook. In this chapter number 20 indicates the ball and roller bearings. If you see this one, these are the ball and roller bearings, and these are the formulas what we are using in the design of ball and roller bearings. So these are the formulas. Okay, let's see what are the terms involved in the equivalent load. So if you find out the equivalent load here, V into X into FO plus Y into FA into S. So this is the form what we are discussing here. And let's see, we are already defined V is the race rotation factor. The value of race rotation factor here consider we are 1 from the design data book. Why? Because in case of inner ring rotation and as well as the outer ring stationary type of bearings, we are consider 1, and in case of inner ring stationary and outer ring is rotation condition, we are consider a race rotation factor value is 1.2. This is about the consideration of race rotation factor. Go to the X and Y. That X and Y are the radial and axial load factors. How we are consider the radial and axial load factors? So for that purpose, using the table number 20.5, it indicates the equivalent bearing loads. By using these equivalent bearing loads, if you find out here we have a different type of bearings like a deep groove ball bearing, angular contact ball bearing, self-aligned ball bearing, and spherical roller ball bearing. These are the types of ball bearings or maybe roller bearings. So based on this condition, how we are consider X and Y values? For that purpose of X and Y values, here we are taking the a ratio of axial load to radial load. When we are taking the axial and radial load ratio, with the help of that value, we are equating this E. For example, here I am consider the FA by FR, that is equal to 0.37. At this condition, we are consider the X value and Y values. So this is about the consideration of X and Y values. Go to the next one, service factor. Here how we are consider the service factor. If you find out the table number 20.3, it is the service factor value consideration. Here two ways to consider the service factor. First one is the based on the machinery applications, and second one is the based on the type of load. That means it is the constant load, or maybe light shock load, or maybe medium, or maybe heavy loads. Based on these two conditions, we are consider the service factor here. For example, here I am consider the constant or maybe steady load. At this condition, what is the service factor? That is equal to 1.0. So this is about the consideration of requirements in the equivalent load condition. And next one, this is the next step here, life of bearing in hours. So it is denoted by L suffix h, that is equal to L into 10 to the power of 6 whole divided by 60 into N. So it is the form for life of bearing in hours. So let's see here, that L indicates the bearing life in MR, in million revolutions. That means life of bearing in million revolutions indicates by L. So with the help of this one, here we are going to find out the life of bearing in hours. And one more term is there, it is the N. The N is the bearing speed. Bearing speed. It is considered in RPM condition. In some cases, that means in some type of problems, they are mentioned life of bearing in hours. With the help of that one, here we are consider the what is the life of bearing in million revolutions. So let's see how we are consider that one. So LH into 60 into N, that is equal to L. Here the 10 to the power of 6 indicates the million revolutions condition. So this is about the life of bearing in hours. This is about the second step in the design of ball or roller bearings. Go to the next step. Dynamic load. So here we are going to find out the dynamic load. So it is denoted by capital C. So that is equal to L by L10 whole power 1 by K into P. So it is the form to find out the dynamic load here. So let's see what are the terms involved here. Here we already know L is the life of bearing in million revolutions. And after that, L10 indicates the 1 million revolutions. Okay, and next, what about the K? That K is the exponent here. How we are considered the exponent? So that exponent is considered based on the type of bearing. In case of it is the ball bearing or maybe roller bearing. For that value, we are prefer the design data handbook. So if you find out this one, dynamic capacity or maybe dynamic load condition, whatever. So in this condition, here we are going to find out the C, that is equal to L by L10 whole power 1 by K into P. So here how we are consider the exponent? In case of ball bearings, we are consider exponent k equal to 3. In case of roller bearings, we are consider k equal to 10 by 3. This is about the exponent value consideration. So the k equal to 3 for ball bearings. In case of roller bearings, we are consider the value 10 by 3. So this is about the consideration of exponent value, and here already we know what is the P. It is the equivalent load condition. So this is about the third step. Okay. So with the help of this value, we are going to select the suitable bearing based on the given considerations, or maybe based on the given applications. Let's see how we are consider the suitable bearing for given applications. For example, when we are doing this step, we get the some value of C. By using that value of C, dynamic capacity value, we are consider the static capacity value. So let's see how we are consider the static capacity value based on the dynamic capacity value. For that purpose, we are prefer the table number 20.7 and 20.8. Here if you find out, here we have a different type of bearings. Let's see, this is the ball bearing tables. These all are the ball bearing tables, and this is the deep groove ball bearings, self-aligning ball bearings, self-rope angular contact ball bearings. Different type of ball bearings and roller bearings tables are these all are. So with the help of these tables, we are consider the static capacity load. For example, here I am going to design one deep groove ball bearing. In the deep groove ball bearing, I get the dynamic capacity value approximately 7,800. At this 7,800 condition, what is the static capacity value? Consider the static capacity value. With the help of this value, we are going to design a suitable ball bearing or deep groove ball bearing for that application. So let's see. Here I get the C0 value with the help of consideration. What is the value we obtain? The dynamic capacity value. Based on the dynamic capacity value, here we are consider the static capacity value. Okay, go to the next step. So by using this value, we are consider the C0 value based on type of bearing. So this is about the important step here. When we get the C0 value, using that C0 value, again we are going to find out the equivalent load and dynamic capacity load. So let's see how we are going to find out the again equivalent load and dynamic capacity loads with the help of C0 value. So let's see that one. When we know the C0 value, with the help of that C0 value, again we are consider the find out the x and y values with the help of FA by C0 ratio. So when we get the FA by C0 ratio, at this condition we are consider the x and y values. When we know the x and y values, again we are going to find out the equivalent load. So let's see how we are consider the x and y values with the help of static capacity load. So let's see this one. Here also I am selected a deep groove ball bearing, whatever based on the given applications. So that's why here I am selected the deep groove ball bearing. For the deep groove ball bearing, Here already we know axial load. That axial load and radial loads are provided in the given problem. And next, C naught, it is the static capacity. Here that value we are considering here with the help of type of bearings and table number 27.8. This is for deep groove ball bearing. In case of self-aligning bearing, the table number 20.8A indicates here. So that's why based on the type of bearing, we are consider the C naught value here. Okay, when we know the C naught value, with the help of ratio of axial load to static capacity, we get the some value. When we get the some value, for example, here I am get the 0.13. At this 0.13, what is the x and what is the y values? Consider these x and y values. Find out the equivalent capacity or equivalent load again. Again, we are going to find out the equivalent load based on the C naught x and y values. I think it's better to write down FA by C naught x and y values. So again, what we know, equivalent load P equal to V into x into FR plus y into FA into S. So this is about the equivalent load based on the FA by C naught x and y values. Here FR it is the constant value and FA is the constant value. But what about x and y? X and y values are varied here due to the axial load to static capacity ratio. And the race rotation factor is the common, that means it is the constant here, and service factor also constant. Why? Because that applications are, if it is the steady load or maybe if it is the heavy load, whatever it may be, that applications are common here. So that's where service factor also a constant here. So this is about the equivalent load. Again, find out the dynamic capacity value. The dynamic capacity C equal to L by L10 whole power 1 by K into P. Here also the life of bearing in million revolutions, it is the common, and exponent, if it is the applications of ball bearing, that value is common, or maybe roller bearing, that value is common. But if you find out the P value is varied, why? Because the equivalent load here we are find out with the help of FA to C naught x and y value. So that's where the equivalent load is varied here. In this case, we are considering the P value with the help of FA by C naught x and y values value. So that's why. So this is about the dynamic capacity value. So when we get the C value, by using this value, we are select the which type of bearing is suitable for given applications. For example, by doing this dynamic capacity, we get the some approximately value, some x value. Let us consider same applications. Here I am considering the deep groove ball bearing applications. In these applications, I get the C value approximately 9,805. For example, here I am considering only example. When we got the value 9,805, in this condition, let us consider which type of bearing is suitable. In case of Indian standard, the bearing number is 20B302, and a basic design number is 04304, but it simply say to 04. This type of bearing is suitable for given applications. So it is the example for your understanding point of view, and it is the consideration. So which type of bearing is suitable for given applications about ball and roller bearing. So this is about the design process of ball and roller bearing, and in the next class we are going to solve related problems of ball and roller bearings. If you have any queries regarding this lecture, please comment in comment box, and thank you for your watching.